making them. The one camera we do have, it's not red lights.
No.
Yes.
Okay. So, we are Team 401, and we are giving a hoot about safety. And this is how to develop a comprehensive safety program for your teams. So, we are Team 401, we're from Bensdale High School, and why is safety so important, Justin? We know there isn't a safety award anymore, but we think it's still important to develop a safety program for your team, just so your team knows about safety. Because if you have new members coming in, it's not on the top of their mind when they're building a robot. And we have developed 5 steps to building a comprehensive safety program. I guess. So I'm Caitlin Higgins. I'm a deputy safety engineer.
I'm Justin Squares. I'm also a deputy safety engineer.
And I'm Kathy Seidman. I'm a process engineer at Dow Chemical. I've been mentoring with the team 5 to 6 years now, and I am the safety mentor, and I was a previous first safety advisor.
So this is why you're this is why safety is so important. Safety allows our team to work together in a safe environment, ensuring our safety while using tools in our shop that we have at our school, as well as any tools we use in the pit. And it allows everyone to be more aware of their surroundings, making sure that we are prepared for emergency situations. Like last week or 2 weeks ago, there was like a small almost fire, so that, prepared us for that situation. So we have 5 steps to making a comprehensive safety team. Yeah. So we commit to safety. We construct a safety binder, which Justin will hold up for you. It's very hefty. We educate our team members, our old and our new incoming team members. We document safety incidents and hazards. Even if it's a cut on your finger, if you're bleeding, we like to record it to make sure we know why it happened and how you can prevent it later. And we evaluate safety processes each year, as well as, maintaining up-to-date first aid. So step 1, committing to safety. So how can my team commit to safety? By appointing a safety captain. Now, our safety captain had other things to do today, so he couldn't come today, but we have both of us here are deputies, so we are here to present this to you. And as well as establishing a safety committee of people on the team who can be always on top of safety. Now, unlike sub-teams, this is a subcommittee, so you can be on multiple things at once. While if you're building the robot, you can also work on safety. Realizing there's no downside to safety and you can never be too safe. Like, even if it's just a cut on your finger, you want other people to know how that happened and how you can prevent it. And retain flexible with changing conditions such as COVID. It's not super important right now, but it comes back up. So we like to keep that in rotation. This is just explaining more in depth. When we establish a safety captain, we have this thing called a town hall where we appoint all leadership on the team, but we will take a vote and see who should be the safety captain. And the safety captain are responsible for overseeing team safety, the program on and off the season. We maintain the safety binder and any presentations we give to the team. So the safety committee is just like a group of people on the team that we have sustaining our safety program from year to year. And the committee should be interest-based, so it doesn't have to be super big amount of people, just anybody that wants to join and is excited about safety. And they're responsible for getting safety policies and procedures and making sure they're being followed. So if they see somebody on the team doing something unsafe and they recognize it, they'll inform them and make sure they don't do it again. This is just, again, reestablishing what we've already said. So we are setting and enforcing safety policies, making sure our team has proper PPE, so safety glasses and safety gloves. Everybody on the team will have access to safety goggles, and anybody in the shop or the pit has their own pair of gloves to use. And we review and update the team safety binder each year to make sure it has up-to-date information, and we adapt safety protocols as time changes, such as COVID, and that was a weird time, so we adapted during that.
Okay. The second step to constructing a comprehensive safety plan is constructing a safety binder. Which is this. The safety binder is where we house all of our safety protocols. Yeah, to ensure the entire team follows safety practices. We have them all listed in here. We also have safety trainings, how to use every machine, how to be safe around all the machines, how to be safe on the robot, and such. Like I said, what's in the safety binder, safety rules and procedures, training logs, emergency plans and procedures, what to do in case of a fire, what to do in case of a zombie apocalypse.
Or a chemical spill, that kind of stuff.
Our injury reports, anytime anyone gets injured, you write it down, what happened, how you can prevent it. Safety issue reporting, if you see something, say something. And then our inventory checklist of all of our PPE, all the classes, what classes to use when to use gloves, when not to use gloves. And our SDS sheets, which is material safety sheets.
Does everyone know what an SDS sheet is? It's a safety data sheet. So every company that makes and manufactures a chemical has to create a safety data sheet. And included on that safety data sheet is what is included in that material, what chemicals make it up, what type of hazards are associated with it, whether it's flammable, whether it's not flammable, whether it's toxic, whether you can transport it safely. It's got the firefighting preventions, it has storage conditions. It basically has everything you need to know about the chemicals that you have. So if you think about a robot, there are many greases, lubricants, your battery itself, you might have additional things that your team uses. Every chemical that you touch has a safety data sheet. And in the event of a spill or emergency or something along that line, you should have access to that safety data sheet so that you can pull that information, especially like if it's a battery spill or something else or any fire situation, so that the emergency response team knows how to handle what type of chemical is on the ground or floor and how to handle it. So again, look at the chemicals that you might be using, the lubricants and stuff like that, and then we collect every safety data sheet that we have. They do get updated occasionally by the companies, but even older ones has relevant information.
So the third step is educating your team members. So this sets expectations for your incoming and your returning team members on what they should expect on safety and how high a regard we hold it. And we hold a safety meeting at the start of every year or the season where the entire team will go over the board safety, broad safety rules that apply to the entire team, safety reporting and injury or near miss logs, your team's emergency and evacuation plans, and where all of your safety equipment is stored. We keep it in a couple of different locations for ease of access for our different sub-teams. safety, educating the safety is oh my God, an as needed basis. And students are, if they're working on machines or power tools, will need more specific information. So if they're working on like a mill or lathe, or if they're using drills and that kind of stuff in the pit, and students working on the robot, an assembly will need specific training, such as battery spill cleanup procedures, if that were to happen.
Step 4, the safety plan is documenting safety incidents and hazards. Why document an incident? We document incidents to allow the team to update safety procedures and to prevent future incidents and make corrective actions. So we, again, prevent further incidents. We also discuss in the beginning of all of our meetings in our announcements when an incident occurs, so the whole team can learn from the experience and prevent the incident from occurring again. Some ways to document are OSHA 300 forms, which are injury report forms. Also, you create a database of all of your injuries and injury report forms so that anyone can access it at any time.
And every injury report form is signed off by the person that had the injury and the safety captain on duty at the time, and the safety mentor as well.
And the forms are filled out after you've already addressed the safety incident. So it's not like we would let the students lead as we're filling out the form. We would take care and treat the injury first and then do the follow-up afterwards.
And the last step, step 5, is evaluating safety processes each year. So again, we have a safety committee, and they'll look at common issues that occurred during the season, such as we'll pull out all the injury report forms, go over each one, discuss what was most common between all of them and how we can prevent it further. We regularly check the CDC website for most up-to-date health recommendations, such as COVID recommendations. And we check out other team safety programs to see how we can add to ours. And we asked first safety advisors or the UL safety judges at your competitions for things to add to your program, what would make it better, and what you could remove if it's not necessary.
One thing we also have is we've developed a safety app on our team, and also it's on our website. So, like I said, we developed an app for Android and iOS. It's a mobile version of this big bulky binder so that you can keep all of your injury report logs and everything that we explained is in our binder. You can do inside of the app. You can scan the QR code to be redirected to our website, which has details on how to download the app.
And for the app, you can make it customizable for your team and upload your information for it. We are looking to revamp it this year because it's a little bit outdated as far as the type of software that's used for it. But on the website, there is links to, we have instructional videos to help you go through it and how you can upload your own team information on it and have it for your team.
This is just our team website. So we have our safety outreach, our safety binder, the COVID-19 health and safety guidelines and COVID-19 safety measures. So this was all much more important a couple of years ago, but we try to keep up to date with it if anything does change. And all of it is on our website. We keep everything really compact there. So any basics with safety comes before anything else. So having a line of succession, like training a deputy safety captain, if the next safety captain is leaving, finding a safety mentor for your team, like Kathy is, and can be safety, or have a safety professional or someone who is just well versed in safety practices that will come to your shop and train your people or educate them in shop safety procedures, as well as in the pit setting with any tools, anything that we use that could potentially become unsafe. Any questions? Yes.
So how do you guys go about documenting your training?
It's all written down in forms in our binder.
So like, do you mean general training, like general safety training or training on
Or
specific tools? Okay, so when we do our specific tools, we have usually one of the lead mentors that is trained on a tool. Or if in previous years when we didn't have like a shop mentor, we would have one of the senior team members that is very well versed in the actual instrument itself or the tool that's being used. And they would train the incoming students on it before they're even allowed to touch it and use it. And then for documentation of it, they would sign off on the form saying this person has been trained and is okay to use the instrument or tool. Depending on the mentor or the student that's doing it, sometimes they would like the student to actually use it while they're being supervised to demonstrate that they understand the safety concepts behind it, how to turn it on, how to turn it off, how to safely, like in the case of like a sanding machine or something like that, how to safely put the tool in and not put yourself in the harm's way. And all that would be hands-on, depending on each piece of equipment that we would have. And then documentation is just literally signing off when they're okay to use it.
Especially with our major tools we used in the season, the CNC router, the lathe, and the mill. Those are the big ones that we do our metal machine work on, so that's really important.
And we never let students use the tools or equipment without a mentor presence, which is first. Just that's where the biggest chance of getting an injury is going to happen, and you need to have at least a mentor present. To make sure that if something happens, they are able to respond to it properly.
For a team that's like starting to think about safety after they're started, do you guys offer like other teams to come in and kind of scope out your safety training modules?
We haven't had that, but we'd be more than open to it.
I know Wood used to run it,
Okay.
and just something to toss in your.
Yeah, I mean, our team, we would welcome any team to come into any of our meetings at any point in time. If you want to look at it specifically for safety, that would be fine as well.
Yeah. I think that'd be valuable to the veteran. I mean, some veteran teams
Yeah.
and some of the new teams that are coming in our area.
Yeah, no, I mean, our doors are always open to any team that wants to come in. All you'd have to do is just contact us and make sure that, we know you're coming, and then we would give you a tour and, let you see how we run things. Go through some of our stuff in more detail and stuff like that. So if you were looking for a particular area like the shop or something like that, we would definitely make sure our shop mentors are available at that time. We have a whole group of mentors that, are kind of focused on different areas, so.
Well, when you say like each mentor or the mentor or an expert student would be the one running the training session, obviously it would be a junior or a senior.
Usually, yes.
Right.
Yeah.
What happens when that student leaves?
So hopefully you're training the younger ones,
Right.
so that when they become the junior or seniors, then they would do it. Usually we do have now 2 shop mentors, but immediately after COVID, our primary shop mentor wasn't coming back to the school initially because of the COVID concerns. And we didn't have anybody in our shop, and that was a weak point for us, and we were relying on our senior students. But they were coming back from COVID too. So even though they were trained on the tools themselves, we realized it was a gap. And now we have the one shop mentor came back because COVID is less of a concern than it was a couple of years ago. And then we also found another shop mentor that helps them out. And between both of them, we rely on the mentors to do it. And then we have had a couple students step up, and we always had a shop lead mentor or our shop lead student that manages the training and everything underneath the kids.
And we're very lucky because we usually have a really high influx of new members going either shop or assembly. So we always have a constant stream of new members that are always being trained for years to come.
And then in a really bad pinch, then hopefully you can get somebody else that just graduated, or, we have a partnership with like our tech school, and they came out and helped us with our CNC router at some point. So, You might be able to find either a local company or another school or something that can come out even just for 1 or 2 meetings to help in that situation and provide like support or training just for your team.
What do you guys see as like the leading cause of injuries, either within your team or FRC as a whole?
I would say we have a lot of like small like hand injuries, and those usually happen in the pit. You get pinched, you get cut by something, and we try to prevent that as much as possible with gloves, but in some instances, gloves can't be worn for more safety reasons, like in the shop, like there's like, you can explain more about that.
Like, in the shop, you can't be wearing gloves when running a, say,
Rotational device.
yeah, like a milling machine or lathe. You get that glove caught in your spindle, that glove gets caught in there, and it pulls your hand in there with you, and now you have no more appendage on the left side.
So I would say the biggest cause is inattention to
Yes.
the tasks that you're doing. Whether it is using a tool and not waiting for it to 100% stop, which you would think would be obvious, it's not. Especially with students, like they're thinking, oh, it's slowed down enough.
You can
With
touch it
tools,
now.
you can never rely on it, and even though there's a stop and you train them over and over again, it only takes a split second. So it's usually that inattention to the task that you're, full inattention to the task that you're doing.
Or I also feel like it's getting too comfortable around the tools you're working with. It's good you get comfortable with them, like using drills and such. But if you get too comfortable, you'll lax in your attention and you won't be as aware of your safety, and then you'll get hurt. In a lot of cases, I've seen that happen. Anything else?
No, I've got a question if nobody has anything. When you run your safety training for the new members, is it just one tool and they're walking out, or is it a series that you guys just pick an afternoon or evening or weekend and everybody just gets trained together?
So we do general safety training for all new members and all team members every year, and we pick one of our regular meetings, and we just go through, everyone's responsible for their own safety, when safety glasses are required, the general overview of safety. For these specific shop tools, that is usually done over a couple week periods with the mentors and the students as they're going through it. So it's not like we pick one tool one day.
Right.
It's kind of depending on what tasks we might be doing. Sometimes we just generate like something to CNC just for the sake of training.
Right.
Something small and simple, and the mentor works with the new students to go through it. So there's a couple approaches that way, but we don't really have a set schedule. It's kind of, and each student might learn a little differently, where a couple students might need a little more time than others that pick it up right away.
Like for example, in our shop the other day, we just got our influx of new members a few weeks ago. Our shop lead came up with this one part that teaches them how to use a CNC, a mill, and a lathe. That's their part, and they're working on it, and they're learning the machines as they go. And as they go and learn it, they're learning all the safety procedures and things like that.
And for like our shop area, we try to have it where it's not just random access. We only keep shop members in there while it's going on, not just like business people or anyone else to randomly come walk through. As soon as you enter our shop area, safety glasses are you're automatically putting them on. If we see you without safety glasses, we tell you to leave and go get them. So that's one of the few areas that 100% of the time you need to wear safety glasses on. So we do treat that one a little differently, and of course there's no horseplay, but if we see kids goofing off, like we tell them to leave, like there's no eating in the shop, like the general rules like that. We have other areas for that type of stuff. So we try to keep the distractions as minimized as possible.
And in our pit area, we have like cubbies essentially. Everybody keeps their PPE, their safety glasses, and their gloves, and any other things they'll need. There's instances where they won't need to wear them, but we insist they wear safety glasses almost all the time, because you will have to in the pit competitions. And there's a lot of things we're doing. We're getting really up and close and personal with the robot, and things that come flaying out at you. So we make sure they're almost always wearing them in the pit area as well.
Any other questions? Yeah, we're done like early, but.
We got a better turnout than last year. Last year we had 2 people watch our presentation.
I've got some questions if we have time.
Yeah, we have time.
So I'm from 5181. We've been around for 11 years, and it's being a teacher and trying to do this program. It is not the easiest thing. So there's a stint right now of students who feel safety is very important, and we just developed a safety program after 11 years. We had goggles, we had gloves, the whole 9 yards, right? And it was just under, knock on wood, we haven't had a major injury yet, but this is a crew that's gonna make difference, leave their impact on safety, I think. So that's why I'm asking these probing questions. And we devised, we have a bandsaw, chop, lathe, CNC, which nobody knows how to use.
Talk to Justin.
What are you using? What CNC do you have?
At our shop,
Yeah.
we have an 8-bit CNC router.
Okay.
But my training's in Haas machinery.
So we have all these tools. So we devised a mechanism that they have to build. Typically, the normal quarter 20 holes, riveting tool, things like that. So they have to make this block and then attach it to a 2x4. And that was their check off that you attended the safety lesson, or the training, if you want to call it, where you had the classroom safety stuff. Then you built this one piece where you got some experience on how to use the tools. You're still not using the tools by yourself yet, because the kids are coming up with this, where we didn't feel that they were comfortable as a freshman to be walking up to a bandsaw and cut a 1/4 inch Lexan in a straight line.
Mm-hmm.
So we have to watch them over their shoulders, and we devised it together. So we were okay with it. And there were still students who felt uncomfortable using a drill. We had 15 freshmen, 3 walked out without being certified in using the drill.
Yeah, and I
After 2
would say if a student is uncomfortable using a tool, do not force them
Yeah.
ever to try to use something that they're not comfortable with.
So I don't know if you guys have this, but one of the things that the adults more so than the kids, every student on the team had to be safety certified.
Okay.
That was like the low bar mandatory requirement, because we don't want a student saying to another student, oh yeah, I know how to use it. And we have an injury because they were, and again, in that situation, the 2 kids that walked out, or 3 kids, not being able to drive a wood screw in the wood. So everybody has to be certified on our team.
Yeah, so our team is large enough, and we have technical, we have non-technical.
Mhm.
We have everyone split into different subgroups. So we have a dedicated manufacturing group that uses all of the large machinery.
Right.
We do have other ones that help, especially during the beginning of build season when you're building the field,
Mhm.
using drills and stuff like that. And if people aren't comfortable, we have enough other people that can go in and throw a hand in.
So, if you had a student who's a programmer and that's all he's doing, does that person not need to be certified in safety?
So we do the general safety training for everybody.
Okay.
And that is the only training that they would need. A programmer specifically, if they are working on a robot, they need to understand how the robot works, the hazards associated with it. But we don't have a particular safety training for non-manufacturing people.
Okay.
Because it's usually the larger tools and instruments that cause the issue. A programmer, they need the general safety area training. They need to know when they need to wear the PPE, when they don't need to wear the PPE, the hazards associated with everything. And in the general training, we have about, the potential energy, electrical energy, those type of hazards. And usually with programmers, we go through the function of a robot in general.
And being the expert in the room, what's your personal take? I don't wear gloves when I'm picking up the ball. because the gloves that we have in the shop don't fit me. And I bring my own in if I'm
Yeah.
working with, if I know I'm gonna be sanding aluminum all day, I'm gonna bring my gloves in from home. But what's your take on students picking up the bot and wearing gloves or not wearing gloves?
So most of the time, we do not wear gloves or picking up the bot. I know in competitions, they do have it. I think you need to look at your bot in particular. What we actually started attaching to ours is we end up putting hooks
Yeah,
and then a strap on top of it so that it makes it easier to pick up.
But
We actually
even
have
then-
somebody in our school stealer straps, so we have to make them again. But that made it so much easier to pick up a robot compared to like students that were alumni that came back, they're like, wait, you have straps on your robot and you can actually lift it without having to try to figure out your hands around the buffers, and it just made everything so much easier.
and you guys just integrate that into your design when you.
Yes. So depending, you're always gonna have a frame.
Right,
The hooks go onto the frame.
Right.
And then depending on, if you have an arm or anything around it, usually you can get the small hooks that then you just have the cantilevers, that just attach to it, and that's what they're called.
Yeah, we actually usually bend the hooks a bit too, so they're not like in the way from the bumpers and everything, and then we can just hook the carabiners on and hook them off.
And then you have one student on one side that has one strap, one on the other, and then they communicate and look together. We had a student that was the first time they were picking up the robot, and they weren't sure how much it weighed. So they didn't lift it as much as they should have, and that caused an imbalance. So learning from that, again, we were just like, okay, we need to kind of stress the importance of doing it at the same time and making sure that they're ready to lift with all their weights. It's not that they weren't capable of doing it, they were just not expecting the robot to weigh as much as it is. So you look at it and you have no idea to judge it. So even something as simple as that, we stopped and then like said, okay, well, make sure you're talking to your counterpart. Because the student that was lifting it the right way, then it was, almost the whole robot weight. And
So I'm the assembly lead for our team, so I lead the building of the robot. So we make sure we establish once it's built and during the process of being built, how to lift it, how to operate around the robot, when to wear your gloves and when not to wear your gloves, and how to use everything in the pit safely.
what are your shop hours typically when you're in season?
When we're in season, we have it running the whole time we have meetings. So our normal build season meetings are Monday, Wednesday, Friday, and Saturday. Monday, Wednesday, during the weekday would be 4 to 9, and weekends are 8 to 4.
8 to 4. And
So we always have, as long as we have something that needs to be manufactured in our shop, we're allowed to use it.
then the times fluctuate as the season progresses. We'll go in more days in the same hours, Monday to Friday and Saturday. And
Yeah, like the week before competition, we're there like 7 days a week. So, we always try to make sure that we obviously have a mentor. If we don't have a mentor there in the beginning, we don't allow anything in the shop to occur, or even in the pits, until we have enough mentors there that can, supervise the students in the middle.
we have a pretty large space. We have a separate shop, we have a CAD room, and we have 2 large open spaces. One that's like, it's separated by like cabinets. We have a lot of space to cover, so we won't work until we have enough people to cover that.
Do most teams have like common safety drops? Cause my team's been around for 25 years, but last year we had 150 students and 3 mentors.
Oh, wow.
So yeah.
Wow, that's crazy.
Kudos to your 3 mentors.
Yeah.
What do we have, like 50 something members?
Yeah, we're around 50 some mentors, and I would say we have about 6 to 7 that are regularly there. We always try to have at least 1 or 2 there right as school dismisses. And then when the workday is over, we'll have more filtering through around like 5 to 6.
We were laughing because we have more mentors than we have students.
Wow.
The last few years, we've had
One-on-one contact. Everybody gets a personal mentor.
So we have like 50-ish members, but then it will fluctuate who shows up when, like, we'll usually have like maybe 30 or less at a meeting at a time probably. And then like 5, 6.
Yeah. And then in build season right before competitions, if you look at all the different parts of the robot that have to be built, not all members have to be at every single meeting. So like sometimes our business team usually only goes Wednesday and Saturday because that's all they need to get their stuff done. Programming might not need to come until closer to the robot built because there's some stuff that they can do ahead of time, but until everything's assembled, there's not a lot they can do on the actual robot and test out. So.
Can I make a recommendation for that? Because we had idle hands and it was like, come on, guys, you guys can get this done. So we started just putting a motor on, just having all the guts put together, have them wire it, and just put flags on the end of motors to get it to spin, and they can at least start running, and then fine tuning they have to do.
Yep.
It worked out great for our
So that's what
season.
we're trying to do this year. It did not work as effectively last year. We do have like a skateboard or like a demo bot that it's just to get them to practice the code. They can move motors, they can move a few things. But it's always the programmers that are the last ones to get to work on the real robot because to move the arms and everything else that you need to do for the game that you're trying to address, you can't really test all of that out. Like they can do a little bit. We were trying to do some last year, but it just didn't work out until the robot was actually built.
We had the issue where the programmers always complain, oh, we don't get the bot in time.
Yeah.
I'm like, what could we do to solve this problem? Because I'm tired of hearing we don't have the bot in time when I can sit there and
We talked
code it.
about that last year. We're like, there's so much you could do ahead of time.
Right.
Like we have a skateboard, learn to load code onto that. The motors, we've been trying to do a lot in the off season. So programming was definitely something we struggled with a lot last year. Our main programmer was also the chief engineer. And then we had another programming lead that just didn't know the code well enough, didn't teach very well. We have no programming mentor, which is one of the gaps that we do have is we don't have anybody that's well versed in it. So we have very smart students that know coding very well.
What do you guys code in, Java or?
Yeah.
Have you guys looked at LabVIEW?
I don't know.
The bar is much lower and we get our guys to, so what we'll do is we'll test all the motors in LabVIEW and teach the freshmen how to do it. And then the programs, knowing that the motors have been addressed and all that, then the adults would hand it over to the programming team. Now you guys can use this motor however you want.
So I think what hurt us a little bit is in the prior years and all of our robot code was set up by people that knew a lot of the programming. And when they couldn't dedicate the time to it, we have programming code that they were trying to use and not everyone was versed enough in it. Fortunately, one of our freshmen last year, well-versed in programming, he's trying to revamp our programming team and coding so that it's a little more user-friendly and a little more functional other than having like 1 or 2 people that know all the ins and outs of it, and that's not supportive when they're not fully available. So, yeah, I mean, we realize that, but all of our code was based on something more advanced and
we're really trying to build up our programming and our CAD teams because at the moment they're a little small and they're more, we have senior members that are more versed in what they're doing and we're going to lose them. We have really strong assembly and shop and like business programs. Because they usually are most popular. They're like, oh, they get to use big machines. We get to put the robot together. So everybody likes to like flow towards those. So we try to advocate for our programming and our CAD members this year. And we've actually gotten a really big influx in both of them and actually lower attendance numbers in assembly and shop, surprisingly. So we're happy to try to fix that this year.
Does your school offer computer science?
Yes,
it does, yes.
we have computer science and a bunch of like shop-based classes, engineering classes.
And do you know if they're using Code HS?
I don't know. I haven't taken one.
Is your computer science teacher using Code HS?
I have no idea. I mean, I know there are C++ classes, there are Android classes, there's Java classes.
All those languages can be taught with using Code HS, and then what can happen? This is what we started doing at LaSalle. We got 1,200 kids and, a lot to do. So to maximize the number of students that could take programming independently of a teacher. Like all these kids that are here with me, they're taking a lot more classes than a typical kid. So I have them registered in a robotics, like a coding class if they wanted to, and they can learn on their own. And then that would allow your team to be that much well-versed, because you have the basic programming learned, right? And then if you can negotiate with the academic affairs.
If you understand the coding logic,
Right,
it's really just the syntax that changes between all the
Between,
different
yeah.
languages. So it's really, our new programming lead has been trying to teach more of the methodology and the logic behind everything, and then the syntax will follow.
We also
So-
have like two like separate branches of programming. We have our app development and we also have our robot code development as well.
So we're trying. I'm trying to think of what they use for the coding on their own. I can't remember it. What do they have them do?
For what? Oh, I know, they work on skateboard a lot, that they'll work on.
Yeah. No, but it's the free online learning classes and stuff like that, and I can't remember the name of it.
When I learned programming, they gave me a presentation.
Yeah, I know, we stopped using this presentation. Yeah, we were using some of the free online, I can't, Code Academy, that's what it is. So we would have them go to Code Academy and start doing some of the basics from that.
so take a look at this. Code HS is also free.
Okay.
The only thing you won't get is whether your code is correct or not. But that gives you enough syntax. And this is guys who've also got an internship in programming. That was the code, that was the program that was best utilized for what it came with
Okay.
in terms of the overall package and what adaptability I had as a teacher to let a kid who, we don't even offer the course, but he can go on his own.
Okay.
So it gives you the most bang for your buck.
The other thing that we started doing is, the main, programming person would write bugs into the program and then
That's
turn
fine.
it over to the ones learning it and say, what's wrong with this? And try to see, hey, can you figure out what's wrong with it? Why is it not working? And my daughter, who was in 8th grade last year, she's really good at programming and she's starting to figure things out and stuff like that. So now being 9th grader on the team, she's actually doing one of the presentations with, the sophomore now. So we are getting there. It's just last year we definitely struggled with it.
There has to be somebody in Ben Salem who knows how to program.
Yeah, and it's interesting because they're both doing like, my daughter's taking the programming classes in school.
Mhm.
And the programming teachers now, they're like, oh, wait, robotics, and like, he might be interested in joining and helping. So we might be able to rope him in to help with that.
Okay, godsend.
Yeah, I mean, it's,
I teach programming. I don't program the bot.
okay,
I'm not doing it. We have another mentor, former parent who works independently and he's able to give up hours and work with her. I just don't have the patience to deal with them.
yeah,
Like, I
so
need time
I've
away.
never done robot code. I've done control systems at my work and stuff like that. So I know ladder logic, I can think logically, I'm better at going through and troubleshooting. I could not probably start, and teach somebody robot code. So, like, I always wanted to be like, oh, I'm sure I can figure it out. The time I would need to do that, I was just like, no. I know we sidetracked off the safety, but.
Sometimes their programmers will be in the pit and they'll be like, yeah, but we don't know what's going on. And we'll be like, it's not our problem. It's obviously not our problem. You have to troubleshoot to figure out how it's a problem on your end. We checked out through everything. It's not a us problem.
Programmers often like to blame the mechanical stuff.
They always like to blame us.
So when you guys are designing your bot for the season, do you guys integrate your sensors early in the season once the actual design of the bot has been
We try to.
agreed to?
We try to, we never do.
We try to.
What we ended up doing last year, which our chief was very smart in doing, he took motors in wood and built a mock-up of it, and he took all the sensors and motors and LiDAR, which was a godsend last year.
LiDAR was amazing last year.
And he programmed the bot before he got the actual robot.
Right.
because he took our old ride base that we call it a skateboard.
Yeah.
We took our old skateboard and he built on top of it. So it was a full working robot,
It just was made out of like.
just made out of wood.
Yeah.
And then we would attach weights, so it had like the right weights and
Right.
stuff like that properly, so,
Yeah, we're doing the same thing. We'll take last year's chassis
yeah.
and we'll strip it down, or last year's box, strip it down to the chassis, keep it together so that they have some of their programming, and then start making things out of wood. And the kids are now started doing this, so it's like, you kind of step back a little bit.
Yeah.
And that's a huge time saver. And then from a safety standpoint, like, you're shutting the mechanism off before it gets to that point where something catastrophic happens.
Right.
So I'm trying to get these guys to think about programming, but at the same time, like, let's not run the bot into Mr. Rhodes for the 5th year in a row. Every year, they run the robot into one of the teachers.
Yeah, so I mean, some of the other stuff that we do is we'll try to put like mechanical stops in if we can't use sensors. So we've done that on some of the arms where it just prevent it from going all the way back. We've tried to put limits in, and some of it was like we struggled 2 years ago when we went from CTC to Rev and going to the Spark Maxes and stuff like that. The limits and the setup of that was different than our team was used to, because the setup and the interfacing was totally different, and that it had, the Rev products have a lot more capabilities, and they weren't used to all those settings. So like we ended up burning out motors because we didn't realize it was set up right, and then we would burn it out, and then we realized it was just the settings that we didn't have correct in the Spark Maxes and stuff like that, so.
Dude, I hope you didn't throw any of the motors away,
No,
Okay.
we built
Because you
them,
keep-
some of them.
because you can rebuild the motor.
Yeah,
We learned that the hard way too. We overwound and shredded the casing. So like, wait, don't throw it away. There's a reason why there's screws on the shell.
okay, yeah.
So we kept it, and luckily we were able to take 2 broken motors and get one traded away.
But you can also broke some Spark Maxes somehow.
Yeah, we burn out Spark Maxes.
I don't know how we did, but we burned out like multiple Spark Maxes that year, and we were like to our wits' end with it. We're like, we keep like every match with something would happen with a Rev product.
It was so bad, we would actually build in spare Spark Maxes that we could just quickly.
Good.
We
Slide.
just change
Yeah,
out.
it's pretty
So
wild.
there was a lot of teams who've been doing that, and I don't know what it is, but the other mentor and I were talking about, why are we allocating more foot space instead of solving the problem?
Yeah.
And then it was
Well,
like,
you did not have that problem last year, so it really was a learning curve, and then there are just different settings in the Spark Max that we were not used to even looking for.
right.
And it came down to like the students not really reading the instructions and the guides that are provided.
Oh, so we learned that whenever we're doing something new, we're not gonna start building ever. We're gonna watch the video that is tagged along to the package.
Yeah,
And then actually follow it step by step. And this year, it was so much of like calmness in the shop. There was no kid walking up to me and saying, I've got a handful of screws and bolts and hardware, what do I do with it? So it's
yeah,
just
it
like,
was more of an
going
ego
slow.
thing, I think the year before, that they thought they knew what was going on. And they're like, oh, they know everything, and they assume they can figure it out on their own, because that's just the type of students they are, and not having a programming mentor to go through that, and
Thank you very much.
yeah, hopefully this was helpful for you guys. Here, wait, hold on.
You go to a slide. Question. Like this one?
Yeah. We don't both have to.
But yeah, if anybody has any questions, just reach out to
Don't look at the camera.
and we're more than happy to help you however we can.
I tried to download your safety binder and all that,
Yeah.
but I couldn't do it because I'm not a team member. I was like, gotta start somewhere. Let's see who's doing it better than us.
No, and we have our full binder online too. I think it's one of the older, so looking at our website, like I think it's our 2019 binders up there. It's still the general stuff, it's just team members have been updated.
I mean, I don't know where you guys are, I mean, my parents live right behind you guys. so I don't-
Okay, can I get one with Caitlin and then with Justin? So just look for it, just look for it. Put your hand out like this, as if you were talking.
Guys are more than
Like they
welcome.
I'll set up a
with your right hand out.
Yeah.
I'm all
You left one in.
to visit you guys.
Kind of like, make it like this.
Kevin became our mentor, and
Not like that.
he's
Oh
very
my God, bro.
so
I'm
you're
gonna
more than
edit it
welcome to
later.
have your job.
I appreciate that.
Closer and
I'm
closer.
very open to help you.
And he's
I
like the
will-
best CNC person
I
in
will
the
come and
state,
The country, the country.
he's like the best CNC person in the country,
I'm
how do you work for it?
I will come and get whatever insight I can get on getting this thing to work. Because I have no clue how to do it. The kid who does it, he's at Temple University. He's like, yeah, I'll just come home when you get